All right, welcome. Thank you for having us here today. Thanks for sharing your beautiful state with us for the weekend. We're excited to be here. Some of us, this is our second time being at the Weber State Case Comp. Some of us, it's a first time. So we're always appreciative of the opportunities to get these real world supply chain experiences, anything that's firsthand like this. So we really appreciate you having us. We're going to jump right in and look at the objective of the case. The objective that was given to us was to redesign the fulfillment system to reduce costs without damaging delivery performance. And the current delivery performance is about 99.6%. That's awesome. We don't want to change that in any way throughout our presentation. What we did with this objective, we first sat down and we said, with no constraints, with no other things, what would this optimal supply chain look like? We sat down and we talked about all of the different constraints that are in play, the uncertainty of demand, which is a huge influence in this case, the time constraints, especially moving such a long distance, and also the customs and things like that. And also, if ATK were to be operating at their full capacity, the half a plane per day, we were like, this ultimate supply chain would look like producing a plane every 2 days and shipping it directly to the RSPs. But since that's not the current situation, we did factor in all of those constraints into our decisions. And so what we're going to do, instead of completely overhauling and redesigning this system, we're going to walk through the supply chain step by step, starting with orbital ATK all the way through the RSPs, and talk about little things that we can change to make things more cost efficient. So to jump right in, at orbital ATK, there is a huge amount of waste. We don't have a dollar figure on this because we weren't given the cost of goods numbers, but 8% of whatever that figure is. And there are two really important things that we don't know here: the cost, and also why is this waste so large? Why is there so much defect? Is it something that's happening along the lines? Is it happening when it's being formed, cured afterwards? Is it a technology issue? Those were all questions that we had. Also, is it something that there were parts getting damaged in the warehouse, something that you could speak with employees about? And so the first step that we thought was to start tracking those defects, find out why they're happening, when, where they're coming from, how much it's costing, and how you're going to solve that problem. You could even go as far as implementing a quality management system. Of course, Kaizen or zero defects is always the end goal, and that's not always obtainable, but it's something to strive for, especially in the future where you're ramping up to 8, 10, and 12 planes per month. Keeping that 8% number down is going to be a huge part of being cost efficient at the orbital ATK plant. And now Amber's going to talk about a couple other ways to chip away at that waste.
We've thought of a few different ways to cut down on our waste, and one way we came up with, what if we put the inspection or put in an inspection before curing, or somewhere that's earlier in the supply chain, so that way we're not working on already defective product. We're wasting time and money that way. Another is recycling parts. For the scrap metal, they just said they put it in the landfill. But what if we can recover value from that metal, or that carbon fiber, There are several recycling plants over in Europe. They have a lot stricter laws over there for reusability and recovery value, and they can take the off-spec scraps from the cutting, trimming, off-spec, etc. To recover value from that. They can make it into different things. They can make it for hoods for cars, or the roofs, or rear support seats. They can also make it for the inside of the planes, so we can get some of it back. We can also use it for sporting goods. And there's a lot of different ways that we can recover value from that. CFK, Value Recycling, already works with Airbus. They have a long-term disposable contract with them. Boeing has a contract with Materials Innovation Technologies, and they took the F-18 planes that they had and made them into convertible parts. They had a cost savings of 20 to 40%, or that is what's typical of recycling plants, or of the recycling plants. So let's say we have $100 million in our budget. 8% of that is defective. So that's $8 million. If you can recover 20 to 40% of that, 20% is $1.6 million that you can recover. 40% is $3.2 million that you can cover. So I just think it's more cost efficient that way, and it'll cut their costs down a little bit more.
So when we first looked at this case, we thought of a bunch of different data analysis that we could do, and we tried to find ways around the lack of data that we had. Our first attempt was to look at length, width, height of the products in order to see about the maximum number of parts that can fit in each different size of box. The second attempt we made was to look at the optimal shipping mixes to get those products over to Europe. And we didn't have enough data in order to perform solvers for that, as well as with the third option, we didn't have enough solvers to run data. We didn't have enough data to run solvers for the finding the minimum number of shipments we can make and also minimize costs. With our fourth attempt, we kind of just took a step back and realized we were getting a little bit too in depth with data that we didn't have, and we tried to look at it from a different standpoint and made two basic assumptions: that the parts capacity they gave us was correct, as well as that the number of parts we were producing per month was the 4,000 required to make 8 planes. So one thing we thought about that we were throwing around and would think would be cool if it doesn't already exist to create would be software that allows the company to put in what they're producing each day, and in order to run that through their systems in the most time-efficient way to produce those parts, as well as the most time-efficient way to pack and the most space-efficient way to pack those parts. So in order to continue with the ship when finished ideal.
Next we have ramp up. So first off, if we were producing at the current levels we are right now, the ideal for shipping would to continue to ship through air. This is through non-reusable containers. This will save a lot of time because shipping on a ship or a freighter will take up to 26 days, which is a long time. For long-term planning, the first thing we should probably look to do is to increase production. If we can increase production, then we can slowly start to phase out using primarily air as our shipping method and convert over to using ocean or freighter, and we'd be using the reusable containers. However, with this said, there are some products that ATK sells that are too small or too big for the container, so we will have to ship a very small amount of parts through air still. But primarily, in the long run, it would be more cost-effective to ship through the sea. Next, that gives us the agility. So at current producing levels, it's smarter to ship by air because it's a lot quicker. This also makes us very perceptive to change. So if a customer changes what they want, or the demand changes, we can change that very quickly.
So again, before we go into the shipping combination that we would recommend at current production rates, we'd like to remind you that we didn't have as much data as we'd like to provide, and it would be really interesting to be able to look at that data and provide more detailed analytics. So here are 3 different combinations we looked at. The first combination is kind of a base case, which would be 24 of the largest air containers available, which would fit all of the parts. This would lead to a total number of parts being shipped at 4,200, which is a little more than the 8 planes per month, and the cost per unit would be $59.10. For the second and most optimal solution, it would result in 29 boxes being used, with a total of 3,950 parts being shipped, and a cost per unit of $56.81.
So what do we know for sure? Operating costs going above target is not an option at this point. However, bringing costs down is going to require a lot more than maximizing the way that we ship. It is going to require a collaborative partnership. It's going to require attention to detail, as well as constant communication across the entire supply chain. We strongly recommend Orbital ATK to create and form a strategic alliance with Crane and their revenue sharing partners through information sharing and knowledge brokering. However, easier said than done. That is going to require a couple things. It's going to require willingness and connectivity throughout the entire supply chain. And as far as knowledge brokering, it's going to require a little bit of openness and vulnerability. For example, we looked into the wind turbine manufacturing industry that also works with similar material like carbon fiber to produce uniquely shaped products. I would like to approach them if we had the opportunity to see how they solved our problem. Perhaps they already solved our problem and we just don't know. In addition to that, with Airbus showing interest in the collapsible containers, I think that would be a really good opportunity to bring Crane into the conversation as well. From pre-planning to execution, getting together will allow the opportunity for creativity. Perhaps maybe we need to change our order and fulfillment systems. Perhaps there is a way that we all can do mode optimization as well as cargo design for our products. In addition to collaboration, we also strongly recommend a centralized EPR system so that we can capture better forecasting data and have the information that's missing right now to do and conduct a better analyzation of the best practices, the best, most effective cost to bring costs down ultimately. As well, enabling data sharing can create an automatic order fulfillment system, allowing for steady state operations that Orbital ATK is in search of.
So we realize the problem, which is we lack the steady state of operations. And this is mainly caused by uncertainty. We're not sure how many parts do we need to provide at what time and how often do these RSPs order. So in order to avoid this uncertainty, we did we thought about a couple of solutions. The first one is we thought about analyzing, so we're going to forecast the historical data and see how often do each of these RSPs order some specific parts. And based on that, we can know how often this specific part is being ordered. And then we can do a systematic or automatic ordering process that's going to process these parts and send them to this RSP within a certain day or a day. That will help us reduce the amount of certainty that we have because we're going to do automatic ordering system. Now here's an issue. Maybe the RSP will not need it. So we have to regulate this process somehow. So what we're going to do is we're going to place into either 24 hours or 48 hours cancellation period that you can cancel this order because it's going to be automatically processed because we need to process this order in order to be certain that this amount of orders are going to be processed so we can keep up with the inventory. And that's why we suggested the integration of this ERP systems because each one of these entities will have system already. But they're not integrated enough to share all this data and know when, the system will not know when this RSP is going to need this specific part. So it's all not, all of this is causing the uncertainty. So an integration of the system will send us the information that they need in order to process the orders automatically. And then if there's a cancellation, that's going to be, they can do that within the amount of time that we are sticking. The second two things that I want to talk about really quick is the safety stock. We decided to keep the safety stock as a ready-to-go stock because some orders, and in some cases, there's going to be some exceptions for sure. So the exceptions, for example, are going to be like one of the RSPs are going to need the specific part within 24 hours. So we already have this safety stock, or we have this ready-to-go stock. We're going to send it to him. And since we already integrated to the system is going to notify us that our safety stock or our ready-to-go stock is missing this part. So we're going to send it and keep it in Telebrick just for in case another RSP requested that part within an urgent amount of time. Other than that, the normal situation is going to be the normal ordering system, just going to automatically order until it goes to the RSP. The last thing that I want to talk about is the trucks between, because we're sending to 5 different locations from Telebrick. So if we, since we talked about the system that's going to manage our each part, and that's going to help us if we know how much each package can hold, how many parts, in order to maximize the capacity in each package. That will help us determine how many parts you can provide each truck, so we can maybe deliver to 2 cities with 1 truck that will reduce the amount of trucks that we need to use over there, and this will increase efficiency as well as it will reduce costs for sure. So we decided this integration system should be a bit wood-based, so all the executives in all these entities can go online and check all the status in order to let us know just as soon as possible in order to process this automatically for installations.
To kind of recap, we decided not to focus on an entire redesign of the supply chain. We would rather focus on taking the current supply chain and improving the cost efficiencies within that supply chain through maintaining our agility and our ability to respond to customer needs in the uncertainty of demand, as well as to focus on reducing the defects and saving some costs there. Back to the optimal solution, we decided to use 29 different boxes to ship 3,950 parts at a per part rate of $56.81. We didn't have all the data to compare that to their actual current cost per part, but that would be something that ATK could look at to further improve the data we looked at.
One other thing that we want to loop back onto the beginning, we were also posed the question about the ship what is finished rule. Would we keep it or would we change it? And as a team, we collectively decided that we would keep the rule as is for now because of all the uncertainty. If the integrated ERP systems, if more data, if any of that could help eliminate the uncertainty, that rule may change. But for the time being, utilize that factory in Tilburg to its fullest extent. It clearly was put in place for a reason, and it did save $40 million. So we don't want to go away from that rule just yet. When it's produced, we want to ship it, get it across the sea, get it through customs and closer to the RSPs, because at this point, if you were to do away with this rule or to change the rule, it'll almost be negating that $40 million savings. So we just want to thank Orbital ATK again for this opportunity. It's invaluable to us as supply chain students to have this hands-on experience. Also, Weber State and the Fawcett's, thank you for hosting us, and the SASC for planning the weekend. Are there any questions?
We want to thank the judges too.
And the judges. Sorry.
Thank you for being here.
So, do you propose any changes at all to the way they ship today?
So that kind of goes back to they're primarily shipping by air, and we would like to continue with that in order to keep up with the demand uncertainty. But with the other things we talked about further along in the supply chain, we would be able to change that and ship more by ocean. Does that answer your question?
So for now, you're just saying leave it alone.
Until we get more production, and then once we can get ahead of a little bit, then we can start shipping by sea, and it won't mess up the already production or mess up the already time frames. Did that answer your question?
So your price per pound or whatever that price per unit analysis was just based upon doing things the same way that it's being done right now, correct? As far as a mix of air and sea and all that good stuff.
Predominantly, yes. But we do believe that by utilizing more shipments per month, I think from when we toured the factory, they mentioned that they ship every Thursday. So by possibly shipping, what I showed was 6 times per month, so 2 additional times, that might allow them to use cheaper methods of shipping by air.
Can you go back to the chart that had your $56, $81 per unit price? So does this take into account the production rate and how we are ramping up?
So this does not take into account that it's shifting from 10 planes to 12 planes, or from 8 planes to 10 planes to 12 planes. But that would be a very simple analysis to do by just shifting these number of mixes to look at that total number of parts number.
Okay.
And that would be the optimal solution if demand was more certain. We would use the combination mix.
So on this here, so we had, was it 29 boxes? I'm looking at the second row in there.
Yep.
I'll call it B.
Sorry.
I like it.
Okay, so for B there, we had 29 boxes, 3,950 parts, and so that would be the total within the boxes?
Yep.
The total all combined in there?
Yep, no, totally combined.
And so would that be the total for the month?
Yes, that would be a monthly total. I apologize for that. And then, as you can see, like we took this monthly total cost right here, and then I expanded that over to the full year.
So you offered a number of pretty innovative solutions. Let's say you were pitching this to some decision makers. Which is the most low hanging fruit? Which one do we get the most bang for the buck on? Because I really didn't see dollarized savings. I mean, we have a problem with costs. Which of your proposed solutions provides the most opportunity to recover some of those costs, come back into the right side of the expenses here?
I do think that the biggest dollar amount is going to be in the shipping category. We should have provided a dollar figure for the exact cost savings that you would be getting if we had all of the data necessary. Another part is that waste. That 8% is going to be a huge, huge factor of waste in the actual plant here.
So if most companies do have go by Six Sigma, so they have defective parts per million, and they're going by percentage. So if we can get that waste down, that would save a ton of money, at least 8%.
Did you look at, kind of asked on that before there, but other shipping methods or anything, beyond going straight to Tilburg? Did you look at going directly to the RSPs or some other out-of-the-box or crazy idea?
I mean, I talked about briefly just in our optimal solution. If we knew demand perfectly and we could send them by ship over that 30-day journey, consistently, that would be more optimal to send directly to them. But that's just with the demand uncertainty at this point, that's just not an option.
What data do you feel like it would have been, additional data would have been most helpful to you? What would you have done with your case analysis?
So if we had exactly like the current cost per unit that they were using, we only had like a percentage overage that they were using. So if we had that cost per unit, we could look at, is this optimal solution up on the board really optimal, or is it currently where they're at? I feel like that would have been the most valuable in order to save money in the shipping aspect.
Thank you. All right.
Thank you.
Thank
you
you.
very much.